Buffer solutions are solutions that resist changes in pH, assuming that your buffering capacity is not exceeded. So, what is an example of a buffer solution system? A weak acid and its conjugate base. So, for example, I could have a weak acid like acetic acid, and then when it loses its H plus, its conjugate base would be the acetate ion. So this would be, now ideally you'd have equal moles of weak acid and its conjugate base would be an ideal buffer. So what happens if I add a strong acid indicated by H plus to that? The H plus would be absorbed by the acetate ion and convert that to a weak acid. So essentially it converts a strong acid to a weak acid, which doesn't affect the pH as much as a strong acid would. Let's go the other way and say I added a strong base such as OH minus to it. That OH minus will be absorbed by the weaker acid right there and convert that to a weak base. So it's going to convert a strong base to a weak base, which will affect the pH, but not nearly as much as a strong base would. So the buffer system has a weak acid and its conjugate base there. The acid absorbs excess base that's added. The base part absorbs excess acid that's added. And it converts strong acid or base added to weak acid or base, so therefore it doesn't impact pH as much. If you add more strong acid or more strong base than you have of this right here, you will exceed the buffering capacity. And then if you add H plus, you'd see the pH plummet, or if you were adding excess OH minus, you'd see the pH skyrocket in that case. We could also make an argument for a weak base and its conjugate acid. It would work the same way. A weak base of NH3. If you put that in water, it breaks up into NH4 plus and OH minus. If I add H plus to this system, it's absorbed by the NH3, and what happens, it converts that NH3 to NH4 plus. I add H plus, it'll take away the OH minus, it'll drive the equilibrium this way, making NH3 convert to NH4 plus. If I add OH minus, it's going to react with NH4 plus to form NH3. It will react with the weak acid part of this, or the conjugate acid part, converting it to a weak base. So it does work the same way. If I add H plus, it's going to convert the strong acid added is going to be converted to a weak acid, such as this, which doesn't affect the pH as much. And if I add a strong base, that strong base is going to be converted to a weaker base, which won't affect pH as much, assuming I don't exceed the buffering capacity. So that's it with buffer solutions. They resist changes in pH as long as the buffering capacity is not exceeded.